So a very good morning to all of you. Hope you all are fine at your places. Now we will discuss about the numerical of transient analysis, and in these numericals are basically based upon the dual switch. The dual switch means at t is equal to 0, the switch is at position A or a B, and suddenly at t is equal to 0, the switch is moved from particular position to another position, and you have to calculate the value of the current when you move the switch at point from one point to the another point. So if you see this type of numerical on your screen, now in this numerical it is seen that for the circuit shown in the figure, the switch K is at position A for a very long time. Suddenly at t is equal to 0, the switch is moved from position A to position B, and when t is equal to 0, the switch is moved from position A to position B. We have to calculate the current flowing in the circuit, and also we have to calculate the current at t is equal to 6 microseconds. So that means you all know in transient analysis, the current is basically dependent upon the time. And in this numerical, you have to calculate what is the value of the current. And after calculating the value of the current, you have to calculate the current at a particular instant. And the instant is time t is equal to 6 microseconds. So you have to calculate the current at 6 microseconds. So this is the circuit which we have to solve. Now, if you see the circuit, in this circuit, we have a 10-volt battery with the two terminals, that is A terminal as well as B terminal. We have 3 ohm resistor, we have 2 ohm resistor, and a 10 Henry inductor. The switch K is in between A position and a B position, and it is right down in this circuit that the switch K is at position A for a very long time, and suddenly at t is equal to 0, the switch is moved from position A to position B, and we have to analyze the current, what will happen when the switch is moved from position A to position B. Now, if you see, we know that we start our analysis at t is equal to 0, and at t is equal to 0, the switch is at position B, and when the switch is at position B, the circuit will become look like that. We have a 3 ohm resistor, 2 ohm resistor, as well as inductor of 10 Henry. The circuit is closed. Now we can apply the KVL in the circuit, and when we apply the KVL in the circuit, according to the KVL, the algebraic sum of all the voltage drops in a closed loop is equal to 0, or in a closed loop, the source voltage is equal to load voltage. So accordingly, what I have to do, I have to write down the equation that Vs is equals to VR1 plus VR2 plus VL1. But since in this circuit there is no voltage source present, so your source voltage Vs is equals to 0. But 3 ohm, 2 ohm, 10 Henry, these are all the load. So accordingly, the VR1 is equals to 3I of t. Reason being it is a resistor, and in case of a resistor, voltage is equals to I into R. So I is equals to I of t, R is equals to 3. So VR1 becomes as 3I of t. Similarly, VR2 will becomes as 2I of t, and VL1 is equals to L di by dt, that is 10 di by dt. I can substitute these values in the above equation. It will becomes as 0 is equals to 3I of t plus 2I of t plus 10 di by dt. When I add, the equation will becomes as 0 is equals to 5I of t plus 10 di by dt. So up till stage, anybody having any doubt, he or she can ask me, or otherwise I will continuing it. So shall I continue, or anybody having any doubt?
Yes, sir.
Shall I continue?
Yes, sir.
Yes, sir.
Okay, fine. So you see, when I apply a Laplace transform, you know that Laplace transform 0 is equals to 5I of s plus 10 di by dt. Laplace is si of s minus I0 negative, and I0 negative is nothing. It is basically the current flowing through the circuit at t is equal to 0 minus. So here the point that you should must be noted down, at t is equal to 0, the switch is at position B. But in the initial condition, whatever the the initial condition is t is equal to 0 minus, that is before switching. The switch is at position A, and we all know that in initial condition, the inductor is replaced by short circuit. Now, at t is equal to 0 minus, the switch is at position A, and in that case, the circuit will become look like that: a 10-volt battery, a 2 ohm resistor, and this inductor will be get short circuited. And when you calculate the short circuit current, that is I naught 0 is equals to 5 ampere, by simply using the law, Ohm's law, V is equals to IR, I is equals to V by R. So I is equal to V is 10 upon R, that is 10 by 2 is equals to 5. So you can get a value of I0 negative as 5. I can substitute this 5 ampere in this above equation, where the equation that is 0 is equals to 5 I of s plus 10 bracket start S I of s minus I0 negative, and your equation will look like this thing. So you have 0 is equals to 5 I of s plus 10 bracket S I of s minus 5. I can open the bracket, get the results, and finally what we are getting I of s is equals to 5 upon s plus 1 by 2. By simple modification, by simple we can use the mathematical equations, and you are getting I of s is equals to 5 s plus 1 by 2. But you have to calculate the current in the time domain, and in order to calculate the current in the time domain, we know we have to apply its inverse Laplace transform. And when we apply the inverse Laplace transform, what will happen? The inverse Laplace transform converts the signal from frequency domain into a time domain. As I had already tell you in my previous lectures that Laplace transform is a technique by the virtue of which we can convert a time domain equation into a frequency domain equation, and inverse Laplace transform is a technique by the virtue of which we have to convert our frequency domain equation into a time domain equation. So here we are getting a frequency domain equation, that is I of s is equals to 5 upon s plus 1 by 2. And when I simply apply inverse Laplace transform this equation, this I of x becomes as I of t is equals to 5 e raised to power minus 1 by 2 into t. So this is the current that flows in the circuit when the switch is moved from position A to position B at time t is equal to 0. This is the first part of the numerical that you have calculated. Now, in the second part, you also had to calculate the value of instantaneous current, and the time for that current will be given to you is 6 seconds. That is 6 microseconds. Micro means 10 raised to power minus 6. So what I have to do, simply I can substitute the value of my t as 6 into 10 to the power minus 6. That is 6 microseconds. Micro means 10 raised to power minus 6. So when I substitute this value as 6 microseconds here, you can get equation that 5 e raised to power minus 1 by 2 into 6 into 10 to the power minus 6. Either you have to solve it, or you can just like that thing. This is the required answer, that the current flowing in that particular dual circuit when the switch is moved from position A to B at 6 microseconds is I of t is equals to 5 e raised to power minus 1 by 2, 6 into 10 to the power minus 6. So this is all about your first numerical of dual switch. So anybody having any doubt related to that numerical, he or she can ask me. Yeah, anybody having any numerical? Oh, sorry, anybody having any doubt?
यस सर, ओम्स लॉ जिस जगह यूज होता है वही.
आई एम नॉट गेटिंग योर आंसर क्वेश्चन. क्या कह रहे हैं आप?
जहाँ पर ओम्स लॉ यूज होता है ना सर,
हाँ जी,
वहीं से समझाना.
कहाँ से ओम्स लॉ कहाँ से शुरू होता है? कहाँ यूज किया मैंने ओम्स लॉ?
I1 is equal to I1 plus I2.
हाँ जी,
जहाँ पर यही इक्वेशन आपने लगाई सर, R is equal to V by R1.
10 di by dt.
Yes sir.
You see, here we have, in case of inductor, the voltage across inductor will be given by the formula L di by dt. So you see in this numerical, the value of inductor will be having a 10. So it is 10 di by dt. So it is, formula will be that I can use is 10 di by dt. In case of resistor, the voltage will be equals to V is equals to IR. So here we can use 3 into I into 2 into I. So when I get the value, that value will becomes as, if you see the equation, like 0 is equals to 5 I of t plus 10 di by dt. Now after that, what I have to do, I have applied the simple Laplace transform. So 0 की Laplace 0, 5 I of t की Laplace 5 I of s, 10 derivative की Laplace होती है s I of s minus I0 negative, where I0 negative is the current flowing in the circuit at t is equal to 0 minus. Okay, so at t is equal to 0 minus, what will happen? The switch is at position A, and when the switch is at position A, or you can say that at the initial condition, the inductor is replaced by short circuit. And now when inductor is replaced by short circuit, we have to calculate the current through the short circuit terminal. So the circuit is look like this thing. So here I is equals to V by R, that is 10 by 2 is equals to 5 ampere. I can substitute this value in 5 ampere, and after
Okay,
that we
sir.
can get the results. Yeah, now it is clear, Akhtar?
Yes, sir. Yes, sir.
Now it is clear to all of you. So anybody having any doubt related to that particular, he or she can ask me. Otherwise, I will switch over to the next numerical. Yeah, shall I proceed to the next numerical?
Yes, sir.
Okay, fine. Fine. So in the second numerical, you see, this is exactly the same numerical that we have discussed in our previous, but only one difference is that thing in this numerical, instead of one battery, there are two batteries. That is, one battery is having a value of 100 volt, and another is a battery of having a value 50 volt. And both these batteries are connected with a switch 1 and 2. The K is the switch, and we have a load of 10 ohm resistor and a 3 Henry inductor. Again, in this numerical, you can see for the circuit shown in the figure, the switch is at K is at position 1 for a very long time, and suddenly at t is equal to 0, the switch K is moved from position 1 to position 2. You have to calculate the expression of the current with respect to the time after switching. So again, you can see in case of this question, at t is equal to 0, the switch is at position 2, exactly same that we had done in previous. That is a 50 volt, 3 ohm, 3 Henry. I can apply the KVL in the circuit. Source is equals to load. Vs is equals to VR plus VL. Here, source is equals to 50 volt. VR is equals to R, that is V is equals to IR, 3 into I of t. VL is equals to L di by dt, that is 3 di by dt. I can substitute these values as 50 is equals to 10 I of t plus 3 di by dt. Okay. Now I can apply the Laplace transform as I had already done in previous numerical. When I apply the Laplace transform, it is 50 by s is equals to 10 I of s plus 3 s I of s minus I0 negative, where I0 negative is the current flowing through inductor at t is equal to 0 minus. Now at t is equal to 0 minus, the switch is at position 1, and when the switch is at position 1, I have made the circuit. Here we have a 100 volt battery, 10 ohm resistor, so inductor will be replaced by short circuit, and we know that when inductor is replaced by short circuit, it is called as the initial condition. Now, in this case, the initial condition current, that is I0 negative, is equals to I is equals to V by R. V is equal to 100. R is equals to 10. So simply I can calculate the value that I is equals to 10 ampere. Now I can substitute this 10 ampere in this equation. When I substitute this value, your equation will look like that. 50 by S is equals to 10 I of S plus 3 S I of S minus I0 negative, and I0 negative is equals to 10. I can simplify these equations by simple mathematics. So finally, your I of S will becomes as 50 plus 30 S upon S into 10 plus 3S. as I had already told you that this I of s is the current at frequency domain, but we have to calculate the current in time domain. So that means we have to get its inverse Laplace transform. But before applying the inverse Laplace transform, we have to get partial fraction it. The reason being, in the denominator, there are two factors look like s and 10 plus 3s. So for getting inverse Laplace transform, we have to get its partial fraction. So what I have to do, I can simply, I of s is converted into two signals, that is I1 of s and I2 of s, where I1 of s is equals to 50 upon s into 10 plus 3s, and I2s is equals to 30s upon s into 10 plus 3s. Now I took I of s as 1 and get partial fraction AB. So finally, you can see that I of s and your I2 of s look like something like this thing. So your I of s will becomes as I1 of s plus I2 of s, where I1 of s is equals to 5 upon s minus 5 upon s plus 10 by 3, and I2 of s is equals to 10 upon s plus 10 by 3. So these all equations are in frequency domain equation, and in order to get the result in time domain, what we have to do, we have to apply its inverse Laplace transform. And when we are applying its inverse Laplace transform, so the inverse Laplace transform is basically nothing, it converts the frequency domain equation into a time domain equation. So you can see your IT is equals to 5 minus 5 e raised to power minus 10 by 3 into t plus 10 e raised to power minus 10 by 3 into t. Okay, I will share this both the numericals on your WhatsApp group. Kindly go to the WhatsApp, downloaded your both the numericals, and try to solve these numerical at your workplace. If you find any problem while solving these two numericals, you can message me or a text me or a call me. I will surely solve your query. Okay, so this is all about for today's lecture, that how a dual switch in a transient can be calculate the current by in a dual switch, where at one particular time the switch is at position 1, and after certain time the switch is moved from position 1 to position 2. Okay, so this is all from my side. If you have any doubt or query related to that thing, you can ask me now. Anybody having any doubt? Yeah, anybody?
No, sir. No, sir.
Okay, fine,
No,
fine,
sir.
fine. So this is all about for today's lecture. I again repeated you, kindly go to both the numericals on your WhatsApp group, download it from the WhatsApp, and try to solve the numerical at your workplace. So this is all about your chapter that is called as the transient analysis. So in our next lecture, we will start with the another unit of another network analysis. Okay, so thank you so much for today's lecture.